We're going to be writing out and balancing equations, and in order to do that, we need to remember how to write formulas for ionic and covalent compounds. I've listed out the basic steps for writing formulas here on this slide. The first thing we have to determine is if we are dealing with an ionic or a covalent compound. And if you'll look at this slide, you will see that what we are really looking for is the presence of a metal. If a metal is present, it is ionic in nature, and we're going to follow the directions for writing formulas on the left. If both of them are nonmetals, we're going to use the directions for writing formulas for covalent compounds on the right. Sometimes words are just words, so let's go ahead and practice those. So when writing formulas, we need to be looking at our periodic table. And you'll notice that I went ahead and numbered the groups because that's going to help me to determine what their charge is if they are ionic in nature. And that also gives me information about the valence electron number. Now, since we're looking for a metal, it would be really nice if we went ahead and separated our table based on metals and nonmetals. And so this line that I'm drawing here is that separation. So everything to the left of that is a metal. Everything to the right is a nonmetal. So again, since we're looking for the presence of a metal, if we have something to the left of that, we know we're going to follow the directions for ionic. Alright, so with an ionic compound, we have charges. And so we know that metals lose valence electron numbers. Since every element in group 1A has one valence electrons, that means that when they lose their valence electron, they're going to end up with a 1 plus charge. So every element in that group will end up with a 1 plus charge. The second group will end up with a 2 plus charge. The third group, for any of them that are on the left of that jagged bar, is a 3 plus, and then this is a 4 plus. The fourth group could also lose, and then when we look at groups 5A through 7A, you'll see most of those are on the right side of that jagged stair step. So these are your nonmetals, and your nonmetals are going to gain electrons, so they'll end up with a negative charge. So if I have 5 valence electrons, I need to gain 3 for stability. If I have 6, I need to gain 2, and I'll end up with a 2 minus charge. And then if I have 7, I'll end up with a 1 minus charge. So those are my charges. Now I have everything I need on the front of my periodic table to be able to write compound formulas. On the back, I've also provided some information. So look on the left, you have your polyatomic ions, and they already have your charges listed. Again, this is the exact same table you have available to you on our Canvas page. So we're going to focus on this section for today. And then here's our prefixes for covalent compounds, and these are the diatomics, which will always be named either oxygen gas or dichlorine, for instance. Alright, let's go. So our first example is sodium fluoride. Sodium is a metal. Because it's a metal, it's ionic. Therefore, we're going to follow the directions on the left of that table. That means I need to know charges. So the first thing I need to do is write out the symbol for sodium. And then I need to write out the symbol for fluoride. The second thing I need to do is I need to add charges. When I look at sodium, sodium was in group 1A. So sodium has a 1 plus charge. When I look at fluorine, fluorine is in the nonmetal side, and it is going to end up with a 1 minus charge. So I need to crisscross or exchange numbers. What that means is that I'm going to give this one to fluorine, and I'm going to give this one to sodium. And I don't write ones. You see how they're both ones? I'm not going to write ones anyway. So what I would do then is rewrite it. It'd be Na, and then I would follow this back. It'd be the 1, but I don't write 1s. And then F, and I'd go to see what I would write there, and it's 1. So NaF is my formula for that. My next example is manganese 2 chloride. So manganese is again a metal. Its symbol is Mn. Chloride. Now here's the thing. You see the Roman numeral? The Roman numeral tells me the charge on manganese. So I know that manganese has a 2+ charge. I look at the periodic table and see that chlorine has a 1- charge. Now remember, I'm going to switch these. So I'm going to take this 2 and I'm going to move it to chlorine. And I'm going to take the 1 and I'm going to move it to manganese, but I don't write 1s in my final formulas. So when I rewrite that, it goes Mn, and then it'd be the 1, but I don't write the 1, Cl, and I write that 2. So they're exchanging numbers. Lithium carbonate. So lithium is a metal, so I'm dealing with ionic. I need to know charges. Now guys, carbonate is on the back of your periodic table. So you're going to look on the back of the periodic table, find carbonate, and write it exactly as it shows you. And it also has already provided you the charge. The charge is listed there as well. We look at the periodic table in the front for lithium, it's a 1+. I'm going to exchange those numbers and then rewrite the new formula. So it's Li2 and then CO3 1, but I don't write 1, so I'm done with that. Triiodine decabromide. So iodine is a nonmetal. Bromide is a nonmetal, so I'm dealing with covalent here. And you see the prefixes? The prefixes always give it away. If you see prefixes, it's covalent. So I'm going to identify the symbols. I for iodine, Br for bromine, and then the 3, tri is 3, and deca is 10. So that's how I would write the formula for a covalent compound. And then finally we have the diatomic molecules, the Hofbrinkel twins I call them. You're always going to see them named oxygen gas or dioxygen, chlorine gas or dichlorine, those kinds of things. Anytime you see iodine, for instance, it will always be written as I2 because, or nitrogen, if one of your equations just says nitrogen, it'd be N2 because that is the only way we see nitrogen in nature, unless it's bonded to something else. Alright, so we got oxygen gas. Well, oxygen gas is a diatomic molecule, which means it's going to be O2. There we go. And I tried to make this short, but hopefully you'll watch this and that will help some of you who are struggling. Thank you very much.